We are going to study about star delta starting of induction motor. Okay, in the previous class we have discussed about which type of starting? Auto transformer starting. Okay, today we are going to study about star delta starting of induction motor. Listen, the starter winding of a induction motor. Okay, starter winding of a induction motor. Initially what we are doing, the connection of the starter winding is star. Okay, when motor catches the speed, okay, 80% of the rated speed, we convert the connection to delta. So initially मोटर का जो कनेक्शन होता है कौन सी वाइंडिंग का, स्टार्टर वाइंडिंग का, वो कौन से कनेक्शन में रहता है, स्टार कनेक्शन में. कुछ टाइम के बाद जब मोटर स्पीड पकड़ लेता है उस टाइम हम क्या करते हैं, स्टार को डेल्टा में कन्वर्ट कर दिया जाता है. ठीक है, तो ऐसे करने से क्या होता है, देखो स्टार में तुमको पता है कि जो लाइन वोल्टेज होता है वो V1 है. सपोज द लाइन वोल्टेज इज V1, R फेज टू Y फेज, लाइन टू लाइन वोल्टेज इज V1. देन टेल मी व्हाट इज गोइंग टू बी माय फेज वोल्टेज, V1 by root 3. So the voltage, the winding is reduced or not? V1 by root 3, that means the winding is getting a less voltage as compared to the line voltage. If the voltage is reduced, then obviously the starting current is also going to be reduced, because starting current is nothing but voltage to impedance. If voltage is reduced, then definitely your current is going to be reduced. Your starting current is going to be reduced. Okay, what is the problem in delta connection? In delta, your line voltage is same as phase voltage. Listen, suppose R phase to Y phase, the voltage is V1. Now tell me what is the voltage across this winding? It is same V1. That is the problem. The winding is directly getting the line voltage. Okay, if the voltage is more, then current is more, and the chances of damage is more. Okay, so initially what you are going to do, the windings, these windings are starter winding. Okay, these three windings are starter winding, and they are connected in which connection? Star connection. They are getting the supply RYD. Okay, after the motor speed up, the connection changed to delta connection. Okay, so initially we are assuming the motor is connected star. Okay, so in star connection, this is the phasor diagram, this is the equivalent circuit diagram. In the equivalent circuit diagram, tell me how much voltage the winding is getting in star? V1 by root 3. So here the per phase voltage is V1 divided by root 3. The windings is getting V1 by root 3, and R1 plus R2 days plus JX1 plus JX2 days. This is the total impedance. Total impedance. So you know the voltage is V1 by root 3, and you know the total impedance is ZSC. Okay. So if you divide the voltage applied, that is V1 by root 3 to the winding, because this winding is getting V1 by root 3. So the equivalent circuit diagram, in the equivalent circuit diagram, you are giving V1 by root 3. So the voltage is V1 by root 3 and the impedance is ZSC. V1 by root 3 divided by ZSC. This will give you the starting current, because the resistance R2 dash divided by S, and my S value is 1. So this current is the starting current, which is equal to V1 by root 3 divided by ZSC. So what I can do, 1 by root 3 and V1 by ZSC. Rated voltage V1 divided by ZSC is ISC. So I can write ISC. Which got you? So this way you can calculate the starting current, and this is a very popular relation. Starting torque to full load torque is equal to starting current to full load current whole square into full load slip by starting slip. Starting slip is 1. Yes, starting slip is 1. So in this formula, this is a very popular formula. Okay, so in this formula your starting current is 1 by root 3 into ISC. So I can replace starting current by 1 by root 3 into ISC. That 1 by root 3 whole square is 1 by 3. I can take out. So the new formula is ISC by IFL whole square into SFL divided by 1. Understood? So this is the formula for starting torque to full load torque in case of a star delta starter. Okay, then the ratio of starting torque with star delta starting, okay, divided by starting torque with direct online starting. Now, how much voltage the winding is getting in case of star delta starting, that is V1 by root 3, and you know that the starting torque is proportional to applied voltage whole square. So the applied voltage is V1 by root 3, its whole square. Okay. Starting torque with star delta starting is equal to V1 by root 3 whole square. Starting torque with DOL starting is equal to, you know that the starting torque with DOL starting is proportional to applied voltage whole square. In DOL starting, how much voltage the windings is getting? V1. So here I am writing V1 square. So the ratio is 1 by 3. Okay, if I take the ratio between these two, 1 by 3 I am getting. So this is very important relation. What is the ratio of starting torque in case of star delta starting to starting torque in case of dual starting? It is 1 by 3. Then suppose I want to start the motor by making a delta connection, not the star connection. Then what is going to happen? Suppose you assume the motor is initially in delta connection. So in delta connection, you know that the winding is getting how much voltage? Directly V1 voltage is getting. So that's why here I am writing V1, equivalent circuit V1. And from this, tell me what is the starting current? Starting current is applied voltage divided by ZSC. So applied voltage is V1 divided by ZSC. But this is V1 by ZSC is ISC. So starting current is simply equal to ISC in case of delta method. In case the winding is delta connected, the starting current is ISC. But your starting current is 1 by root 3 into ISC. Okay, 1 by root 3 into ISC in case of star connection. So in which case the starting current is less. Here it is ISC, here it is 1 by root 3 into ISC. Star connection starting current is less. Okay, so that's why initially I am using star connected winding. Okay, because in star connection the starting current is less as compared to the starting current of delta connection. Then this is everyone understood. Next, line current. What is the line current in case of delta connection? This is delta connection. Your line current is this one, and this one is my phase current. Yes or no? Winding current. Winding में कितना करंट फ्लो कर रहा है बताओ? ISC. Here I have told you ना. Starting current is equal to ISC. That means the winding current is ISC. ISC starting current is equal to ISC. So winding में कितना करंट फ्लो कर रहा है? That is ISC. Okay. How to calculate the line current? If this is ISC, this current must be root 3 times ISC. Yes or no? Because line current is root 3 times the phase current. The phase current is ISC. So the line current should be root 3 times ISC. That's why I have written over here the line current in the delta connection is root 3 times ISC. Now tell me what is the line current in star connection. This is my star connection. How much current is flowing in the winding in the star connection? Winding में कितना करंट फ्लो कर रहा था स्टार कनेक्शन में? 1 by root 3 into ISC. Yes or no? 1 by root 3 into ISC. Yes, because winding में जो करंट फ्लो कर रहा है वही हमारा लाइन करंट भी है. Because in star connection the line current is same as phase current. The line current is same as phase current. Phase current is your winding current. Winding में कितना करंट फ्लो कर रहा था स्टार में? ISC by root 3. So that is same as your line current. So line current I can say ISC by root 3. Everyone understood? Now if I take the ratio line current in case of star, line current in case of star is ISC by root 3 and line current in case of delta is root 3 into ISC. So this root 3 comes down to the denominator. So root 3 into root 3 is 1 by 3. ISC cancel out. So this ratio is 1 by 3. In many of the competitive exams, this ratio is very, very important. Okay, many of the questions asked regarding this ratio. 1 by 3 factor is there between these two current, these two line current. Now coming to this diagram, I have told you initially the windings is in which connection? Star connection. Later it is converted to delta. So this is my proper circuit diagram, how I can convert star connection to delta. So this is my line. This is my line, 3 phase line. Okay. Suppose this is A phase, B phase, C phase. Okay. There is a switch, TPST switch. When this switch is on, then this A phase is available over here, B phase is available here, and C phase is available here. This switch is closed, so if this is closed, this A comes to here. If this is closed, B comes to here. If this one is closed, C comes to here. Everyone understood this? Okay. So at once these three switches connected. Okay. At once. It is a single throw. In a single throw, all these switches are intact. When these three switches are intact, then A moves to here, B moves to this place, and C moves to this place. When it is open, there is nothing here. No voltages, no phase. When these three switches are closed, then A available here, B phase is available here, and C phase. This line is carrying C phase, and this C phase is available over here. Everyone understood this? Huh? Now, these three windings are actually my starter winding. Okay. So now these three windings are neither star connected or delta connected. So these three windings, if there are three windings, how many terminals should be there? Terminals कितने होंगे? 6 terminals. So I have named this terminal. This one is coming from B, so it is capital B. The other end is small b. Okay. Now this winding is receiving from A phase. So this end is capital A. So the other end is small a. I am writing. Similarly, this one is my third winding. This winding is receiving from which phase? Tell. From C phase. The C phase is taken and connected to this winding one end. Okay, so the other end is small c. Now, small a, small b, small c are taken like this. This small a, small b, small c is taken. Here there is a switch which is called TPDT switch, triple pole double throw. That means this switch can be thrown to the left side also and to the right side also. This switch. Okay. So now I have three terminals: small a, small b, small c over here. Yes or no? बुझी पार्छ कि नहीं? So I have three terminals over here: small a, small b, small c. Here there is a E-shaped structure. E-shaped structure. Yes. Again, suppose these three switches are fall to the position 1. Okay. So tell me A, B, C. The small a, small b, small c are sorted or not? Because it is a E-shaped structure. Your small a, small b, small c, all three touches this structure. So small a, small b, small c, all are sorted, and it makes a common neutral point. Understood or not? A, small b, small c. When position 1 is on, then the small a, small b, small c are sorted, and it makes which connection? Because there is a neutral point, so it makes the star connection. These three windings are star connections when my TPDT switch in the position 1. Everyone understood? So first, in the position 1, your three windings are in the star connection, and these windings are getting the supply. Yes or no? These windings are getting supply. Capital A is connected to phase A. Capital B is connected to phase B, and capital C is connected to phase C. So like this. This is my neutral point. Beside capital A, capital B, capital C. Capital A is connected to phase A. Capital B is connected to phase B. Capital C is connected to phase C. And small a, small b, small c, all are sorted and makes the neutral point. Understood or not? So my star connection is ready. Okay. Now motor is getting supply. winding star connected starter winding, motor is getting supply and motor start rotating. Suppose motor achieved is 80% of its speed. Okay, its rated speed is, suppose assume 1500 rpm, motor is revolving around 1400 rpm, that means almost 80% of the speed motor is catched. Okay, under that time what you are going to do to convert the connection from star to delta. So how this connection from star to delta taking place? I have again pressed this TPDT switch. Okay, so now this connection changed from this side to this side, from position 1 to position 2. In position 2, what I am doing, I have 3 terminals. From where these 3 terminals are coming? From B phase. Okay, this is my B phase line. So from B phase I have taken one point. From C phase I have taken one point. From C phase, and from A phase. From A phase I have taken one point. So I have 3 points available over here, which are taken from phase A, phase B, phase C. Understood? Okay. Now when this 3 switch moves to position 2, this side, this switch moves to this side, then small a is connected to capital B, small b is connected to capital C, and small c is connected to capital A. Okay? Understood or not? So when these 3 switches are moving at that time, they are sorted or not? This sorting is now not available. Okay, because you are moving the switch from this side to this side, so this sorting is not available now. So it is open. So freely 3 windings are there. And when this A is connected to B, A is connected to B, small a is connected to B. So listen, here I have 3 windings. Okay, its terminals points are like this: capital A, small a, capital B, small b. This winding, capital C, small c. 3 winding, total 6 terminals. Named capital A, small a, capital B, small b, capital C, small c. Now you are sorting small a is sorted with capital B. Small a is sorted with capital B. Then small b is sorted to capital C. Small b is sorted to capital C, and then small c is sorted to capital A. Small c is sorted to capital A. Now tell me, the winding is now which connection? Delta connection. Initially, when in the position 1, the windings are in which connection? Star connection. Later, when you move the switch from position 1 to position 2, the connection is delta connection. You can feel. Getting the feeling or not? Good. So, the upper ends are capital B, capital A, and capital C. The lower ends are small a, small b, small c. So, a small a, you can choose small a to connect it to any small c or small b also. It is up to you. Like I have connected like this also. Suppose this is the winding. Okay. So capital A, small a. Suppose this is my small b, capital B. This side capital B. This side must be small c, capital C. So this can be your connection also. You can connect small a to capital C, small a to capital C in this way. So from capital C, this is the capital C. You take the point capital C. So small a can be connected to capital C. Small b can be connected to capital A, and capital B can be connected to small c. This way also you can make the connection. It is up to you. But I have selected small a to capital B, small b to capital C, small c to capital A. This also gives my delta connection. Okay, so this way you can convert a star connected winding to delta connected winding by the help of a TPDT switch. Its position will decide whether it is a star connection or delta connection. In position 1, the 3 terminal A, B, C, small small a, small b, small c are sorted. So small a, small b, small c sorted gives you the neutral point, and capital A is connected to phase A, capital B connected to phase B, capital C connected to phase C. This way you have made the star connection. Then when the motor speed reaches 80% of its rated speed, like if the motor speed is 1500 rpm and motor is now revolving at 1400 rpm, then you can switch from position 1 to position 2 with the help of this TPDD switch. And when you moving from position 1 to position 2, small a is sorted to small capital B, small b is sorted to capital C, and small c is sorted to capital A. In this way you have made a delta connection, and the supply is already connected. You are not isolating the supply. Without disconnecting the supply, you convert the star connected winding to a delta connected winding. That is the advantage of this method of conversion. Okay, everyone understood? Thank you.